So welcome back. Now I can go. Thank you, Dan. Okay, so let's get this started again. Got another great presentation from Catherine Royce from SDFC Hartree. Welcome.
Thank you.
You are.
So, I've been the new director for Hartree for the last 6 months, and it's been a really exciting part of my career joining Hartree up in Daresbury. And what I'm going to do today is give you a sort of cornucopia view of what we're doing. Nothing in a lot of detail, but a lot of stuff so that you've got an understanding of what Hartree is doing at the moment. And as we go through, I'll give you sort of some hints and ideas about where my thinking is going around where the organisation is going to go in the next few years. And nothing's moving. Is it that?
Let's try going down now. Perfect.
Hey, thank you. So, working with us, I thought it was worth, just in case some of you didn't know, exactly where we're based. So, our main base is Daresbury Laboratory, which is up here, which is an STFC campus. We do have a few people at the RAL Laboratory at Harwell in Oxfordshire, and we do have STFC's other smaller campus, UK Astrology Technology Centre. We also have a few people there too. As part of our large government funding that we have, and I'll explain to you that it's called the Hartree National Centre of Digital Innovation, or if you get to know it, HNCDI. So if I slip into that acronym, that's what I'm talking about. We are going to set up some hubs, which I'm really excited about. So these hubs will be spreading the message of Hartree around. Hopefully some of you have seen the calls and you've applied. I have to say that we have now closed, but we'll be announcing who the winners are, and we're really looking forward to working with the community outside of the Northwest. So our mission is to transform UK industry by accelerating the adoption of high-performance computing. So we are not a research centre. That's not our pure aim. We do research, but our research is around challenge-led for industry. And by industry, it can be private sector, or it can be public sector, and I'll explain a little bit more as we go through. So what do? We do four main things. What I would like to highlight to you is the one at the bottom, which I think is quite unique, because we are talking about digitally transforming UK industry. There is a large amount of training that we do that is free at the point of access, that goes from complete novice level right up to practitioner level. And we don't have specialist trainers, we actually have the people that are developing the algorithms, doing the data science, working in our current teams that do the training. So that's something well worth knowing. The other things I don't think would surprise you, we do collaborative R&D. That's the only way you can work with industry. If you're going to make an impact, you need to co-design what you're doing. We have platform as a service, which is pay-as-you-go access to our compute power. I would say that we are, as many of you know, looking to procure a new supercomputer soon. We're looking at sort of 23, 24. And we're looking to have that pretty much as an AI accelerator, at least the majority of it. So we're all quite excited about that, and I can talk a bit more about that later. We create digital assets, that's not surprising, it's what we're doing, and of course I mentioned the training and skills. So I wanted to reiterate again about the fact that it is very much about the transformation of UK industry, UK PLC, right? That's what we're here to do. Now, we have our several funding models. HNCDI is one of them, but we have lots of other different bits of funding which help us do that. And I think that also I'm going to hint at something I'm going to come back to towards the end, is that I very much think that at the moment we need to gain insight from ever-increasing sizes of data, as you all know, and looking at accelerated discovery and AI, HPC, and quantum, and how that is going to span that area is of huge interest to me at the moment. In terms of our expertise, we've got quite a lot. We don't have a lot of domain-specific expertise because we'll get that from the industry that we're working with, but we do have domain specialists within areas that cross-cut. All our projects would cross-cut our main group, so we'd bring in an RSE, a computational scientist, we might bring in an AI expert, and they will work together across that. We do have a big chemistry and materials team, mostly because in the northwest it has been a hotspot. Unilever, AstraZeneca, there's a massive within Liverpool and Manchester University on materials and on infectious diseases. So that has always been a strength up in the northwest, which is why we have quite a big group. We can't work on our own, and this just gives you a selection of some of the partners. Some of you will recognise yourselves here. But we do work a lot with different organisations. We are trying to work closer and closer together. So you'll see that NQCC are here, Alan Turing are here, that these institutes, we do need to develop and improve our collaborative relationships. But we also look at the place agenda and about how to improve the Northwest and how to bring in the talent to the Northwest region where we're situated. We work with lots of different customers, and I just thought it's quite useful to see a whole load of them on here. Some of them you'll know, you will have all heard of Airbus and Unilever, etc. But there will be some on here that you won't have heard of, because we do span the range from startup all the way up to big global internationals. And why do we work with everybody? It's because everybody is on a different part of their journey. If we are going to help UK PLC be that global leader in AI and digital technology, then we have to encourage the big global internationals to look at new things and do new things in different ways, as well as supporting new startups as well. We might be helping them optimize their code, but what we wouldn't be doing is being their CTO for them. That's not what we're here to. We're there to advise, to train, to support, to enable. In terms of where Hartree work, it's worth pointing out that yes, we do work around with emerging technologies, and a lot of our quantum work, I would put it at quite high TRL levels, or low, depending which way you want to go. Most of our work is on that 4, 5 and 6. With the deployment side, we would hope to be able to step off at that point and give that to the organisation that we're working with and let them develop it. There's occasions where we might stay a bit longer on that journey, which is why this is right out here on 8, but we really would like to enable that organisation to do it for themselves. I'm going to give you a few case studies. I'm not going to go into a lot of detail, but I wanted to give you a flavour of some of the work. And if you're interested in anything that we're doing in this sort of area, come and talk to me and I will connect you in to the specialists that we have. And I'm very fortunate to be working with a fantastic team, as I know some of you have already worked with a lot of the staff at Hartree. Unilever, as I said, we've worked with them for a very long time. I think it's really quite exciting because they are moving now to try and very considered work to move themselves off using petrochemicals for things like the shampoos and those sort of products. So how are they going to do it? They don't want to be using wet chemistry to be doing that. We've done a lot of work with them on the virtual lab and on working with them. And I think that's a strength of HPC work anyway within the materials and chemistry area. So again, I think I spoke to Paul Howes when I first started and I said, can you give me an idea of how much we've actually enabled? He won't write it down on paper, but it is. He did say, oh, no, it's global and it's billions. So in some ways with public sector organisations like myself, we do need to, one of the things Hartree needs to work on is actually getting these things actually written down. We do work on some quite fun stuff. I like this because it's the rail, British Rail, and we're all thinking about the British Rail. I have to say I was talking to one of my data scientists, Louise, who was working on this, and she goes, it's a bit odd, I think something's gone wrong today because there's nothing happening. I said, but it's a rail strike, Louise. So we'll have some fun. And then she was like, But she also was able to test it out. So again, we're trying to help even public sector organisations do better. If you've ever been to Hartree, you will probably have seen a demo of the virtual wind tunnel that we've done. We've worked with bespoke car manufacturers. Again, we're reducing the cost it's going to cost to develop these cars. It takes a lot of money and effort to develop a physical car and put it in, and wind turbine, virtual wind tunnel, sorry. This is one that we've done that. We have an entire piece of kit that they can do as a pass type access onto that sort of thing, and we can do it with any types of car. What was very interesting with this study, which a lot of you may well have come across, is when you're looking at the virtual world, putting a car in a black box and then showing how the wind goes off it is one thing, but what they actually needed to do to understand and feel like they're in a real world was actually make the virtual wind tunnel look real, so that when they were stood there with the headsets on, they felt like they were in a real environment. And that's a really interesting thing to go when you're starting to work with industry specialists on what they want to be able to see in a virtual world. It's not just good enough to show them the bit that you think they're interested in. I think drug discovery and novel drug discovery is something that I expect to see expand. I don't think any of you would be surprised to see this one as a suggestion. We've done a lot of work with AstraZeneca. We have quite a lot of work going on at the moment with several other companies. I think some of the interesting stuff I think is really interesting is around natural language processing. So there is a lovely study that was done with GSK quite a few years ago now, probably about 6 years ago, where we looked at something like 24 million citations within their records of work that had been published, and they managed to put together all sorts of work that was done, and they realised there was a whole set of drug treatments that were not being used for Crohn's disease, but actually links back to being able to be used for Crohn's disease. And that's an amazing cost saving, because you're using drugs that are already out there for a new use. And you think back to the work that people were doing during COVID and the reuse of certain drugs that we were able to do. It's low cost, it's quick solutions, and it can save lives. I have two ones here around companies that are very small. So these are startups. Gamification was a big thing here. How do autistic children understand the world around them? So if you're building them some very complicated app that's doing some complicated data science, it can't look complicated to them at the front, and we have to be able to understand them. So we did quite a bit of work with this company. I wanted to mention Orca, because Orca's a real success story. They came to Hartree at about its beginning, about 10 years ago, as a complete startup. Those of you who know Daresbury site will know that we have an innovation accelerator at the bottom of the hill, and as you go up, the joint venture buildings get bigger and bigger and bigger until you get up to the top of the hill, and these guys have moved from right at the bottom to right at the top. So they started with about 5 people, they're now 150 to 250 people, and they're a fantastic business. So those are again the impact that we can have in Hartree. Aerospace, again, we do a lot of work and a lot of code optimization, and I think that goes back to when we talk about net zero later. There's net zero on the HPC and how we run it, but there's also supporting net zero by running things faster and looking at things in the other way. So I wanted to put that in. So HNCDI, Centre for Digital Innovation. This is 40% of what Hartree does. So it's quite an important thing, and we work with IBM on this one. We work with lots of other organisations and partners for the other 60% of what we do, but this is very much with IBM. We are officially launching this on the 1st of November. If you've received an invitation, please accept. If you haven't and would like to go, please contact me and I'll send you a link. It is a transformative programme. It's split into 4 areas. So Explain is that bit that I was talking about the training, and then we go through Explore, Accelerate, and I know E's had to all be E's, so don't come back to me saying that Accelerate spelled wrong. Accelerate, and then Emerging Technologies. In terms of where we are to start with, in the first 18 months of this programme, we've already started to make an impact. And so you can see how things are moving. And it's interesting, this quantum word is coming up a lot in our world at the moment. How do HPC centres harness the power of quantum computing? So here we've got a little bit about what we're going to do and explain. We're going to train 5,000 people on 55 different training courses by the end of the programme. So it's a big part of what we do. It's not a small part, as I said earlier. On the Explore programme, we will deliver 104 projects over the 5 years, and these are 9 to 12 months period projects, 1.5 years of researcher effort, working together with IBM and STFC. So if a business comes in to us and wants to work with us using this funding mechanism, and for an Explore project, we would be paying for that out of that funding pot. They don't have to put in anything particularly, other than their keenness and the problem. You will be accessing IBM as well as STFC's researchers. When we get to Accelerate, this is about really pushing it out into industry, into BAU. These are much bigger projects. It requires about £300,000 of cash or an in-kind contribution from the organisation that we'd be working with. We would be expecting to have done an Explore project with them first. So we've already reduced the barriers of it, well, it might fail. We've checked that bit and we're now pushing it out. Emerging technology is great fun. It's where a lot of the quantum work is being done at this moment. Again, these are short projects. They're working to look. So we did some work with Ocado around, I always think Ocado, you think of it as a grocer, but it isn't a supermarket really. It's a technology company that delivers groceries. And if you think about that and you go to their sort of warehouses, it's all robotics. The big issue is everybody wants cucumbers, so how do you stop robots crashing into themselves when they're all picking up cucumbers? So we've been using quantum QLM machines to be able to sort of start understanding that a bit better and improving. Even if you speed it up by 10%, that's a big deal for a company like Ocado. So I wanted to sort of move this in terms of where Hartree's thinking, and I'm going to touch a little bit on the sort of R&D programme within us. So I'm really interested in this bit. I think we can say, and I've been told to be careful with this thing, but I think you can say this, we're all here already. It's how are we going to do this, and how are we going to cope with accelerated discovery? If it really kicks off as fast as we think, if we start getting AI being used consistently on HPCs all the time, how fast are we going to see that discovery, and then how are we going to deal with it? I think it's also interesting where we're looking at technology transition, which government, before it got into a bit of turmoil, we were having quite a lot of meetings, and I expect that some of you here were involved around this technology transition between AI, HPC and QC, and trying to get people to understand that it's not one or the other, it'll be what you need to solve the problem. Now, I have borrowed this, she says, off an IBM colleague, but this is how they're looking at it, so I'm not going to take credit for this. But it's quite an interesting point of view. You don't need quantum, particularly for easy problems. That can be done easily. You don't need big exascale computers to do some of the easy stuff. But so what we need to be able to do is to track people and to train industry into understanding what their problem is and what the best technology is for servicing that problem. And then for us, within our industry, it's about how do we design the workflows to enable us to do that. And that's where we're going. I think I just put this up because I thought it'd be quite interesting to see where we're going. We're very interested in next-scale computing. Why are we into next-scale computing? Because if industry are going to use it, they need to see early applications of how you use the full power of an X-scale machine. So we've got a whole load of things here. I think we're really excited to be working with UK AEA, and I will show you, actually before I move on slide, we're also working with Oak Ridge and Lawrence Livermore, and we also had a chat with Lumid, so the Finnish group, of trying to understand from them how they're doing, what could Hartree learn, how could we support our industry people and other public sector organisations in using this fantastic machinery and opportunities that we've got for accelerated discovery. So I mentioned we're working with UAE on developing fusion technologies. I like to say that we're harnessing the power of the sun because that sounds really exciting. But it is, I mean, if we can solve that virtual problem, and this is what this world is so good at, if we can solve the problem of controlling plasma, hydrogen plasma, this is going to give us an insight into how stars operate and access, but also to give ourselves, you know, a fantastic energy source that will help us towards net zero. So again, we go back to the conversation we're going to have later on today about we might be using a lot of power to do this, but can we save a lot of power in the applications that we're using it for? And I thought that I would also touch on the quantum classical. What are we doing? We're really, really interested in the quantum classical computing bit. When do you use quantum? When do you use classical? What are the workflows between the two? What are the industry-related problems that this would really help? So like I mentioned, Ocado, with their logistics work, is proving some great results already. We're also looking at establishing a cluster of quantum computing companies around us. That tends to be how Hartree works. We like to develop business clusters around us in Daresbury so that we're developing that community. And I would say that the importance about developing those clusters is attracting talent into an area. So if you want to really make an impact, what you need to do is invite the best talent to come and work with you. To do that, you need a full ecosystem. So you need to be working with the university sector, you need to be working with the business sector, you need to be able to move people from undergraduate right the way through to sort of leaving as a CEO of their own company. So if we can take people on that journey and keep them within the UK, that is a fantastic thing. So developing these ecosystems within the UK will hopefully enable us to do that. And that is all. And I also have Vasil here because I've pinched a lot of my chief scientist's work in this presentation. So thank you very much.